Hello students, I am Dr. Tanmoy Vishwas. I welcome you all in my channel Chemistry, the Mystery of Molecules. I hope you all are fine. So today we are going to discuss a multiple choice question presented in front of you on this whiteboard. So I first request you, please read the question carefully, pause the video and try by yourself, and whatever answer you get, please write in the comment box. Remember, self-evaluation is essential for improvement and you have to accept your situation. Okay? Please do it. So I believe you have tried by yourself, so it's my turn to give you the right answer. And by the way, before going to details, I have a request. Please do subscribe this channel, and if possible, please support me through Patreon, because without your support, it's very difficult for me to continue this continue upload such kind of lectures for you. Okay. So let's start. So as usual, I first request you student, please read the question carefully. Fine. Because you need to check two things. First of all, what is the reagent or nature of the reagent, and what is the nature of the reactant. Okay. So if you understand these two things, it's very easier for you to answer the question. Now, a simple thing, first part, what is the nature of this reagent? Just look at it. So this is actually a ketone and an aldehyde. Now another thing, what is the reagent? See, sodium cyanide. Sodium cyanide, it's a salt. It's a sodium plus and cyanide minus, and DMSO is a polar aprotic solvent. Okay, means you may consider that DMSO is this, or you can write its canonical form also, this. So what is this? This is polar aprotic, means it solvates Na plus cation. How it solvates? You can think that sodium plus is surrounded by, means coordinated by, six DMSO molecule. Okay, so I am not drawing everything like that. So these oxygens are from DMSO. So when the sodium is solvated, just imagine, when one part is solvated, another part is naked or bare or more active, and that is can act as a good nucleophile. Okay, so from this study you can understand the nucleophile became more reactive. So where it will attack? The electrophilic centers. How many electrophilic centers are available? Actually there is available two. One is this aldehyde and this is ketone. Now question, where it prefer to attack? Obviously aldehyde. Why? Because the attack of nucleophile is governed by a phenomena called Barbier-Rinch trajectory. I have already discussed previously. So, and this phenomena is associated, means this attack is favored, first of all the electrophilicity, means electron density, and second thing is the bulkness attached to this carbon. Okay, so if you look at the molecule little closely, so this is actually a phenyl group. Okay, so this ketone, first of all, these two phenyl groups are significantly bulky. Second, and this has a plus R effect. So the electrophilicity of this carbonyl carbon is significantly lower. Okay, compared to this aldehyde, because one part is hydrogen smaller as well as less bulky. Okay, now another thing, one part is hydrogen smaller. In this case, this carbonyl is in between two phenyl, but this carbonyl is attached to only one phenyl. Okay, so from that point also, this is more electron deficient and less bulky, so it will attack. And now it will open up. So this is H, this is O minus, and this is C. And remember, this is nothing but a cyanohydrin formation, means property of a carbonyl group. So we have understood that this attack will occur. So if attack happens, then ADAC formation, and this cyanohydrin formation is actually a reversible reaction. Okay. So if it is reversible, then obviously I should write this way. Fine. But it has some fate. Now question, what can happen? We know during the benzoin condensation, what happens? Similar type of reaction occurs, but in that case some polar protic solvent also used. Okay, so aqueous is and all like that. That's another thing. And what happens in case of benzoin condensation? Benzoin condensation, it produces, this is OH after protonation, this is Cn, and this proton is significantly acidic such that it is abstracted in the medium at this center, means this aldehyde center became nucleophilic. This is the Umpolang or reverse thermal reactivity. But in this case, that is unlikely. And another thing, if it happens also, will it attack this center? Obviously not, because it is associated with 1, 2, 3, 4 member ring formation, highly strained. Second thing, attached to a phenyl group, not possible. Second, did I give any option where 4 member ring is formed? Not possible. So that thing will not occur. First of all, knowledge. Second thing is common sense, essential in during the solving MCQ. Okay, you may know everything, but you need to know which knowledge is applicable at what time. Fine, we got it. So it will produce this thing. Now this Umpolang not possible. This is a reversible reaction. Another what option possible? One option possible, that it can push and it can attack, and it will open up. So what it will result? This is actually hydride transfer. Okay, so in this case, this will produce O minus. This is the hydride. This is the pH, and in this case, so C double bond O again produced, and this is Cn. Now look at this molecule. First of all, you may think that, sir, why hydride shift happens so easily? For that, you need to understand what is the transition state. See, 1, 2, 3, 4, 5. So this transition state is actually, TS is 5-member ring. Okay, and remember that 5-member rings are planar and proper conformationally oriented. Okay, both 3-member ring and 5-member ring are having a proper conformational orientation, but 3-member has little higher strain compared to the 5-member. So 5-member information very easy. So through this 5-member ring transition state, this hydride shift occurs, and hydride has a significantly higher. You can consider majority of case it has a best migratory aptitude, so that's why it migrates. Second, so if migrates produces this. Now if you look at this molecule, double bond O and Cn, is it stable? We know Cn is like a pseudo halogen. We called Cn minus is similar like chloride, bromide, and if you you can compare this thing with acid chloride, acid bromide, like that. Generally bromide we don't read because not stable. So think about acid chloride. So this is significantly reactive because it's withdrawing. And see, this is also, cyanide is also withdrawing. So because of this cyanide attachment, the electrophilicity of this carbonyl carbon will improve further, because cyanide is not just a group. If you look at, it's like this, and you may consider this like a 1,2 dicarbonyl derivative. Okay, so it is significantly electron deficient. Now second thing, if you consider this versus this, who is more electron deficient? Obviously this one, carbon. Okay, so, and another thing, as I told just earlier, if you think the attack is happening in this way, it's a 6-member ring. If it attacks here, that's a 5-member ring. 5-member ring is having a proper conformational orientation. So attack is favored, point number 1. Point number 2, see, after attack, what will happen? It will attack, it will come back, and it will leave. So what it will ultimately produce? This is pH, this is H, this is O, double bond, this. Now question, remember the nucleophilic addition is irreversible. By logical argument, you can say that, sir, there may be some amount of attack on this carbon C triple bond. I agree, but that's irreversible. And in this case, the reaction following a irreversible pathway. So in this case, cyanide is getting eliminated, left. So that's why reaction will follow this pathway. So what it will produce? This is the product. Now, by the way, just let's try to remember the story in a different way. Different way means, this is the product, our product is this one. Now, see, this is nothing but you can consider intramolecular Cannizzaro reaction type. Okay, because in case of Cannizzaro reaction, what happens? We use strong base. In this case, you can consider this sodium cyanide is acting that way. In case of Kanizaru, the base attack, then hydride shift occur. Similar thing, cyanide attack, then hydride shift occur. And why this attack happens on NDI? Because it's selective. So you may consider like an intramolecular cross Cannizzaro type reaction. Okay. And by the way, I have uploaded many videos on Cannizzaro reaction. Please visit if you have to learn further. So from that point, if you think the story became a little easier, that first attack will happen, then hydride migration. One part is alcohol and another part is acid. Just think in that way. So in this case, what will be the expected product? So this is OH, pH, and this is OH. Simple Cannizzaro, I am not showing this, simple Cannizzaro. And another thing, acid and alcohol, same intramolecular lactone formation, means you may consider this is the dehydration of this. This is just for your understanding, improved understanding I am saying, remember, but remember I haven't mentioned here water. So that's why this pathway forget. But ultimate chemistry is similar. Okay, so this is the overall discussion for this. Now question is, if this question appears in your exam, how can you solve less than 30 seconds? First of all, you need to understand what are the reagents. DMSO, this is actually solvent. Mild condition, lowest time means selective reaction will happen. Okay, and cyanide is a good nucleophile. Where it will attack this versus this? First of all, it will attack here. Fine. Now question, is there any chance of further reaction? Yes. So east will not be the option. So first of then it will shift the hydride, and ultimately if it shift hydride, then reduction means this center. Okay. So if hydride shift this center reduction, hydride shift occur, then okay fine, this part will be alcohol. This intermediate I suggest you to write, and after that it will be attached to this thing. Just write this. And intramolecular, instantly you can feel that okay, this C and this attached, so intramolecular lactone formation, this will be the product. And by the way, a simple common sense guess like simple cyanohydrin, it is not expected that examiner will give. Okay, some reaction will happen. You can consider that another thing possible, this O will get attacked and intramolecular acetyl formation. Means this will not stay, first of all. So, but DJ gave this option, not. So this logic gone. This is cyanide attached, this not possible. Just mention. Second, this water elimination occur, aromaticity gone. Just think from a benzene derivative without any external oxidant, you are getting this quinonoid structure. This is very unlikely. Okay, and this is attached to a very good electron withdrawing, means very good leaving group like cyano, not possible based on common sense. So what left this? So your main competition is this versus this. Since based on your understanding, you can say it will not be surviving the medium, so it will have something. So what left this? And this strategy is called process of elimination. You should learn it properly because during the solution, during solving the MCQ, this is very useful. Okay, so this is the end of this discussion. What we learned, that this in 1,2-di-carbonyl in presence of sodium cyanide and DMSO under very mild condition produces a lactone derivative. Similar like cross Cannizzaro reaction. Okay, so this is the end of this discussion. Thanks for watching. If you really like my teaching, then please motivate me by first of all like the videos, because your like matters a lot, and write your valuable opinion on the comment box, and most importantly pass it over your friends because they will get such kind of teaching free of cost. That is beneficial for them also. Okay, so thank you again. Stay happy, stay blessed, enjoy the study. Bye bye.